All right, so this is 1.6 transformations. It says transformations affect the appearance of a parent function. There are two main types of transformations, and you have your rigid versus non-rigid. You can go and read on that, and I'm going to go and talk about the rules right here. So first, I want to give you a kind of equation you might see. So let's start with y equals a times f of x minus h plus k. Alright, so the translations of down and up, that's going to actually be your k value right here. So this value right there is going to determine your graph going up or down. So if that k is positive, it goes up k units. We would say up k units. Let me actually write this a little bit better. We'll say up k units, and it's added to your vertical, which is y. So y plus k would be your transformation it's affecting. All right, for your down, that means k value is going to be negative. And we would say that is down k units. And just like the previous k is going to affect your y's by subtracting it. All right, next we're going to talk about our left and right movements. And our left and right movements are going to be considered h right here. And one thing about h, notice that's inside the parentheses. So anything inside the parentheses, we use a phrase saying insiders lie. And what that means is it's not the truth yet. You actually have to fix it, right? So it's kind of the opposite of what you see. Now, after you fix the lie, then you write your transformation. So if h is positive, it moves to the right h units and affecting x by adding h to it. And if your h is negative, it moves your graph to the left h units. So it'd be x minus h. All right, and then we have some reflections right here, and that's in the very front of your equation. So somewhere right over here in front of the a. So if that value is negative in front of the a, then it reflects across the x-axis. So the formula you might see is negative f of x. So notice the negative is in front of the whole function, and that means it reflects across the x-axis. You'll see me use the phrase RAT x-axis or RAT x, which means reflection across the x-axis. Now, if your negative sign is inside of the parentheses in front of the x, that's what we call a reflection across the y-axis. So notice on the reflection across the x-axis, it was up here, and now it moves to the bottom. And for the reflection across the y-axis, it's going to the right, and then after it reflects across the y, it now moves to the left. All right, and our last types of transformations are our horizontal and vertical stretches and compressions. All right, so for our vertical dilations or transformations here, this is when that a value, we're talking about that a value in front of f of x. So that's this value right there. So when that a value is greater than 1, we get a vertical stretch by a. And when that number is in front of the whole function is less than 1 but greater than 0, that is a vertical compression by a units. Okay, so if it was negative in front, it would be the reflection across the x-axis. But if it's number, where we just look at the number by itself, it's either bigger than 1 or it's between 1 and 0, not included. Now your horizontal dilations or transformations are going to be found inside of the parentheses with x. Okay, so remember, insiders lie. So what we're looking at is b times x, but to fix the lie, we just multiply by the reciprocal. So we're actually like, it's kind of like dividing by b. So what you should first do is you're going to take that b value, you're going to flip it over. And notice our stretch and compression is going to be by 1 over b. Let me fix that real quick, sorry. After you flip it over, then if your 1 over b is less than 1 but greater than 0, that is a horizontal compression by 1 over b. If when you flip it over it is greater than 1, it is a horizontal stretch by 1 over b. Okay. So again, you take that number in front of x, you flip it over. If it's bigger than 1, it's a vertical stretch. If it is less than 1 but greater than 0, it is a, if 1 over b is greater than 1, it's a horizontal stretch. If 1 over b is less than 1 but greater than 0, it's a horizontal compression by 1 over b. Alright, and then last it says the function will compress or stretch vertically by a factor of, this one's going to be a, which I already wrote, and the other one will be, the function will be compressed or stretched horizontally by a factor of 1 over b. Alright, let's go ahead and apply these transformations here. So it says, given each function, identify both the parent function and the transformations from the parent. Alright, so whenever we do transformations, first thing we want to do is we want to identify what the function is. So this one, the parent here is, it's a cubic function, and the equation is y equals x to the third. Okay, so first thing I'm going to do, I like to make a little xy table here, a little chart. And I write down my transformations, right? So x are my horizontal ones. So right here, there's nothing happening. So we're going to write the word none because there are no transformations happening that are horizontal. But for my y values, this is a k value right here. And it's minus k, so it goes down k units, so down 4. All right, for the next one, we have a square root function. And that's going to be y equals the square root of x. And you'll notice inside, we do have some things happening. So first, you'll see there's a negative inside right there. That negative is going to be right here. So that is going to be a reflection across the y-axis. And we read these transformations inside left to right and outside left to right. So we start with the inside. Reflection across the y-axis. We also have a minus 1. Remember, insiders lie, so that's really a plus 1. And positive h's go to the right, so that's right 1 unit. And we notice we went from left to right on the inside. Now we're going to go from left to right on the outside. And the only number we have on the outside is 2. That's currently being multiplied. And that number is greater than 1, so that's a vertical stretch by 2. Alright, for the next one. It is squared. That is going to be a quadratic function. And our parent function equation is y equals x squared. So for our transformation, starting from the inside, we have a 1/4, which is being multiplied. So for that one, remember, we would take the reciprocal. The reciprocal of 1/4 is 4. And then that is bigger than 1, so that's a horizontal stretch by 4. Alright, for our y vertical one, starting from left on the outside, we have a negative sign, and that reflects across the x-axis. And then we have a plus 6, which goes up 6 units. Alright, number 4. This one has absolute bars. So that's going to be the absolute value. That's going to be y equals absolute value of x. So again, you'll notice this one has the 3 inside factor out already. So make our table. So from left to right on the inside, that 3, first we flip it over. And that number is less than 1, but greater than 0. So that is a horizontal compression by 1/3. We also have a +5 in the inside. So insiders lie, that's really a -5, so that's going to be left 5 units. On the outside, we have nothing in the front. But at the very end, we have a -2, and that's going to be down 2 units. All right, for number 5, again, if you look, we do have a squared function, so that's quadratic. That's supposed to be y equals x squared. So in terms of transformations, we start from the inside. Insiders lie -6, so it's not really -6, it's +6, which means it goes to the right 6 units. On the outside, we have 1/2, which is less than 1. That is a vertical compression by 1/2. That's it for that one. For the next one, so for this one, there's nothing in front of the x, because the x is like that. This is a linear function. So starting from the left, so there's nothing on the inside, but from the outside, that negative reflects it across the x-axis. The 1/4 is a vertical compression by 1/4. And then we have a +3 on the outside, which shows us our graph goes up 3 units. All right. Let's take a look at the next one. All right, this is going to be a cube root function. So cube root, that's because the radical has a hook in it with a 3 in there. And there is our parent function. All right, in terms of transformations, inside the square root acts as our parentheses, outside acts as outside. So inside we have a x + 1, so insiders lie, that's really -1. So that's going to be to the left 1. On the outside, we have a negative sign, which is a reflection across the x-axis. We have a 4 that is greater than 1. That's a vertical stretch by 4. And then on the further outside on the right, we have a +2, which is up 2. All right, take a look at number 8. Again, we have absolute bars. So that's absolute value. For our table, starting from the inside, we have a negative sign, reflection across the x-axis. We have a 1/3, so we flip that over first. That number is greater than 1, so that is a horizontal stretch by 3. And last, insiders lie, that's really a +4, so it goes to the right 4 units. In terms of our vertical transformations, for K, we have up 7. And number 9, this has a square, so that's a quadratic. And in terms of transformations, starting from the inside, we only have 1. That +3 is a lie. So once you fix it, it's actually -3. And -3 moves to the left 3 units. All right, for the next one, on the outside, we have a negative sign. That's a reflection across the x-axis. Then we have a 3/2. 3/2 is 1.5. That is greater. So that's going to be a vertical stretch by 3/2. And then we have on the outside, we have a -8, which shows us to go down 8. All right, next, it says direction using the graph of each function. Identify the parent function, then write an equation for the function under each transformation. Okay. So this is a v, absolute value. So recall our parent function. Okay. So right 4 has to be inside the parentheses. So in this case, our absolute bars act as parentheses. So y equals the absolute value of x. Inside is y, so it's minus 4. Letter C. Reflect over the x-axis and translate it 5 units up. Okay, so y equals, here's the absolute value of x. So reflected over the x-axis is a negative in the front of the whole function. And translated 5 units up, that is plus 5. So our transcribed or transformed equation is y equals negative, absolute value of x, plus 5. Alright, number 11, kind of the same thing. What's the parent function here? This is a rational. And we know we have asymptotes on the x-y axis. Alright, so here our parent function is y equals 1 over x. So 3 units to the left is, we're here with the x, and down 7 will show you that now. So y equals 1 over x plus 3. So that means our graph goes to the left 3 units, and then translate 7 units down, that is minus 7. Alright, and then for letter C, horizontal stretch by a factor of 3, so that 3 needs to go in front of the x. Horizontal stretch by a factor, oh, sorry. Yeah, that was a mistake on my part. So that 3 actually goes on top. It changes the place of that 1 to a 3. That's a vertical stretch of 3. And then translate it 2 units to the right when the bottom with the x is minus 2. Alright, let's take a look at the next one. That is the cube root function. Alright, so the cube root function, it says reflected. Oh, let's write the equation. Alright, reflecting the y-axis, that means there's a negative in front of the x. And translated 4 units to the right, which is plus 4. Alright, and that's our equation. Oh, I forgot the y equals this. Y equals the cube root of negative x plus 4. And then for the last one, for this one, it says a horizontal compression by a factor of 1/2, which is really 2x, and then translated 5 units down, which is minus 5. So y equals the cube root of 2x minus 5. Alright, transformations from a table. So the table below shows ordered pair using the graph of a function that consists of line segments connecting the points in the table. Use the table to create a table of values for each function below that is a transformation of the graph. Alright, so state the shifts and or reflections that f of x undergoes to obtain the graph of g of x, stating what changes are made to which coordinates of f and x to obtain the coordinates of for g of x. Alright, so let's see what's going on here. Over here, our rule says negative f of x, so we're going to write xy. So over here, this negative makes your graph reflect across the x-axis, and the plus 2 needs to go up 2. Alright, in terms of our horizontal transformations, there are none. Now I'm going to write a rule so I can apply this to make my coordinates. So my rule for x didn't change, so it's just x. But for my y's, we reflected across the x-axis, which is negative y. And then up 2 means to add 2 to the y values. Alright, so now we're going to take these points. So our rule is right here. Here's our rule. And now we're gonna use that rule to help us write our table. So the first point, we're gonna take the x and keep it the same. And then the 5, we're going to do negative 5 plus 2, which is negative 3. For the next one, negative 1 comma 1. Oh, I see how I'm supposed to do this. It's supposed to be, once I figured out that one value, which was, we plug in negative 3. No, sorry, for x is negative 3. And it just looks like the x values don't change, so they're all x. Now for the y values, the horizontal shifts and transformations, it says reflection across the x-axis up 2, so negative y plus 2. So we take this number 5, and I'm just going to show you what I'm doing in my head. I'm doing negative 5 plus 2, which is negative 3. Then we have 1, which is 1. We have a negative 4. And so negative times negative 4 is 4. 4 plus 2 is 6. Alright, then we have the 1 here. Negative 1 plus 2 is 1. And then last we have the 5 again. So negative 5 plus 2 is negative 3. And then the ordered pair looks like this, x comma y. Let's see, 1 6, 3 1, and 5 negative 3. All right, there's our list of points. All right, let's see. All right, here's the last example. So the same thing except a different function. So starting with our x's, starting from the inside, we have x plus 2. So inside is y, that's a negative 2, so left 2. And that's all we have for that one. So that's going to be left 2 is x minus 2. And then for the other one, we have the 3 is greater than 1, so that's a vertical stretch by 3. And 3 is going to be, the minus 3 is going to be down 3. Alright, so let's do our x values first. So we're looking at these numbers right here. So left 2, so we're going to do negative 3. Negative 3 minus 2 is negative 5. Negative 1 minus 2 is negative 4. Alright, so let's take a look at our next one. So our 1 right here, we're going to go ahead and plug that in. Let's see what that looks like. So 1 plugged into this one, so 1 minus 2 is negative 1. 3 minus 2 is 1. 5 minus 2 is 3. Alright, for our y values, we plug 5. So here's our rule for this one. It's going to be y and it's going to be negative 3y and then minus 3. So vertical stretch by 3 and then down 3. Alright, so we're going to take 5 first. 3 times 5 is 15. 15 minus 3 is 12. 3 times negative 1 is negative 3. Sorry, let's try that again. 3 times 1 is 3. 3 minus 3 is 0. Now we're plugging negative 4. 4 times negative 3 is negative 12. Minus 3 is negative 15. We plug in the 1. 3 times 1 is 1. 3 minus 3 is 0. And then last we have the value of 2. So 3 times 2 is 6. 6 minus 3 is 3. And now we write our ordered pair. Alright, our next ordered pair is, let's see, let's fix that one. So the first one is negative 4, 0. Then we have negative 1, negative 15. Then we have 1, 0, and 3, 3.